Well, hi everybody. All right, we are going to be graphing tangent and cotangent functions. And y equals tangent bx plus c plus k. Y equals a cotangent bx plus c plus k are going to be the just the kind of the standard or the template equations that we have. All right, when we do this, I'm going to kind of stay with this, that little variation. We're going to flip it if we have to. We're going to sketch it, and I'm going to sketch it in pencil. Then we're going to label it. And then shift it. And then that'll be where our final equation will be. So, and in this, A is the, let's see, it's not the amplitude. It really doesn't have an amplitude. So it's the non-amplitude amplitude. But what it actually is, it kind of shows on the curve on each side of the middle part shows the points of inflection on each side. And the period, a normal period for pi, or for tangent and cotangent, is pi. So the period is going to be pi over b instead of 2 pi over b, like it was for sine and cosine. So it's a period, the period of the parent function divided by b, so pi over b. The vertical shift is k. Okay, and the phase shift, it's essentially going to be negative c over b, but we will look after factoring and just remember our rules when we were doing translations with other functions. It still applies like it did before. And factoring is what I meant to say there. But it literally is this, but we'll talk about that. Now, I do want to just kind of get you to recall what y equals tangent of x looks like, that parent function. If you recall, you have an asymptote on this side and this side. The on tangent of x, the y-axis splits it in half. And I'll just put 3 periods here, and it kind of goes like this, and like this. And remember, this was pi over 2, and this was negative pi over 2, and half of that is pi over 4, and half of that is negative pi over 4. So if I do the same thing, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 is pi, 5 pi over 4, and 6 pi over 4 is 3 pi over 2, and negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4 is negative pi, negative 5 pi over 4, and negative 6 pi over 4 is negative 3 pi over 2. So that's the parent function. That's the one we're going to be flipping and shifting. when we have to. So y equals cotangent of x. If you recall what that looks like from our parent function video, I'll go over here, and here, and another asymptote here, and the y-axis is also one of the asymptotes, and it starts high, and goes low, starts high, and goes low, starts high, high, and curves down and goes low. All right, and it goes from 0 to pi. Half of that is pi over 2, half of that is pi over 4. So that's what our increments here will be. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and 8 pi over 4, which is 2 pi, negative pi over 4, negative pi over 2, which is 2 pi over 4, negative 3 pi over 4. You see what I just did there? Maybe. That's negative 3 pi over 4. Negative 4 over pi over 4 is negative pi. Negative pi. All right. Tangent, cotangent. All right, those are the things we're going to be flipping and shifting. And flipping, labeled, and shift. Okay. All right, so with that in mind, let's look at a couple of examples. Example 1. Y equals 3 tangent x over 3. Okay. So let's first of all, a is 3. The period is pi over 1/3. 1/3 is the coefficient of x here, which is 3 pi. The vertical shift is 0, so we're not going to shift it at all. And the phase shift is also 0. There's no, you'd have something over here if you had a phase shift, and we don't. So we just have this. Now, so there's no vertical shift or phase shift. We just have to get the thing labeled right. So I'm going to just go ahead and graph the tangent function and then label the graph. That's all I have to do here. So let's graph tangent. Alright, so tangent goes, I'm going to do that in pencil here, like so here. Halfway there. And up here. Alright, so time to label. Now, the period is 3 pi. Half of 3 pi goes here, half of 3 pi goes on this side. That's half of 3 is 1.5 or 3 halves. So I'm going to write 3 pi over 2 here, negative 3 pi over 2 here. Half of 3 pi over 2, half of 3 halves is 3/4. So half of 3 pi over 2 is 3 pi over 4. Right here is negative 3 pi over 4. So that's kind of what the increments is: 0, 3 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, which is 2 pi, 9 pi over 4, wait, I'm counting wrong again, 3, 6, this is 9, 3, 6, 9, 12 pi over 4 is 3 pi. 12 pi over 4. 15 pi over 4. Count by threes on the numerator there, numerator coefficient. And 18 pi over 4, which is 9 pi over 2. So negative 3 pi over 4, negative 6 pi over 4, negative 9 pi, trying to be careful, negative 9 pi over 4, negative 12 pi over 4, which is negative 3 pi, negative 12, negative 15 pi over 4 is right here, negative 15 pi over 4, sloppy, and negative 18 pi over 4, which is negative 9 pi over 2 right there on that asymptote. Alright, so we got it labeled. I did not label this. The point of inflection kind of right here. So I'm going to label this 3, 6, 9. This is negative 3 here. To negative 6. I don't have room to write that. Negative 3, negative 9 here. So I've got it labeled. I've got it graphed, and there you are. Okay, let's do another example. And the example I want to do on this one is before I quit, I am going to, when we have to do a phase and vertical shift, my final answer I'm going to use the highlighter to get that drawn. Now, example 2. This time I'm going to do y equals negative 2 times tangent of x minus pi over 2. Okay. Amplitude, non-amplitude is 2. The period is pi divided by 1. So period is just pi. B value is 1 there, pi over b. So the period's pi. The vertical shift, we don't have one right here on this one, is 0. And the phase shift, we do have a phase shift, is pi over 2 units. And I have positive, so we're going to pi over 2 units to the right. Remember, I'll write that. The minus means go right. That has not changed. So just keep that in mind. So let's go ahead and draw our axes here. That's my x-axis and my y-axis. And it is tangent. So I'm going to use pencil here. I'm going to do 3 periods. Okay. And this time it's negative 2. So when that means I do have to flip it, which means usually I'm here, so I'm going to flip those over. So I'll be starting high, ending low, starting high, ending low, starting high, ending low. All right, and the phase shift, I need to go pi over 2 units to the right. So, but I haven't labeled it yet. Remember, you flip it, you sketch it, now you label it. I haven't labeled it yet, so I'm going to label it in a more permanent way here. This is pi over 2. over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, and 6 pi over 4, which is 3 pi over 2. And this is negative pi over 4, because the period is still pi. I need to keep that in mind. If that period changes, I need to also consider that change here. Negative 3 pi over 4, negative pi, negative 5 pi over 4, and negative 6 pi over 4, which is negative 3 pi over 2. Alright, now we do have a phase shift on this one. So we're going to take each one of these, and I like to shift the asymptotes over. We need to go pi over 2 units to the right. So I'm going to take this asymptote and go 1 pi over 2 units here. Okay, I'm actually going to use a more permanent. I'm going to take, that's that asymptote. Let's take this asymptote and go pi over 2 units here. So it's the y-axis is serving as an asymptote. Let's go this asymptote and go pi over 2 units this way. And let's take this asymptote. That's 6 pi over 4, 7 pi over 4, 8 pi over 4 is 2 pi. And go over here with that. And we have the, this is to, I kind of got a little sloppy there, but, and this is, right here, is negative 2, negative 4, that's 4 here, okay. Now, my actual graph is between these more permanent. So I'm going to draw this with ink. Okay, I might just kind of, well, actually I'll leave those. I think shows the journey how we got here, so I think, but we just need to really make it distinct what the actual graph is, and the only part of the graph that are actually ordered pairs that it would fit on the graph are the parts in green here that are highlighted. Now, the one thing I would like for you to notice here is this looks exactly like the cotangent parent function, you know, with that y-axis being there, and we have 2, so this is equivalent to y equals 2 cotangent x. It's the, if I were to graph y equals 2 cotangent x, it would be exactly